Good day, everybody. My name is Vuyisa Maswan, and I'm a solutions architect with Amazon Web Services. We are running a 2021 recap series where I'll be focusing on the database-related announcements. Let us get started. I'll be giving you an overview of the services. Therefore, I will not be diving deep into them. To dive deep, you can always contact your AWS account team. They'll be happy to support you to do a demonstration and link you up with the service subject matter experts. We are also here today to answer your questions. Please type them and we will respond as they come. The slide and the material shared in this session will be sent to you via the email that you use to register for the event. I'll be covering Amazon Rds Custom, Amazon DevOps Guru for Rds, Dynamodb standard infrequent access, the new capabilities in the timestream service, and DMS Fleet Advisor. And we start with Amazon Rds Custom. Sometimes there may be a requirement that you have to access the underlying operating system of your database instance in order for you to configure the settings to meet the requirements of your application. Before this capability was introduced, you would have to host your database on EC2 so that you can have full control. But if you want RDS instance management and have access to the underlying host, this is where you would use Rds Custom, which is a managed service for applications that require customization of the underlying operating system and the database environment. This service provides you the benefit of RDS automation with the access needed for legacy, packaged, and custom application. With Rds Custom, all the resources are provisioned in the customer's AWS account, enabling you to have full access to the underlying EC2 instance and the database environment. Therefore, you will have access to the Rds instance to make customization required by the application as you would in a self-managed environment, while benefiting from the automation that Rds traditionally provides. The service is generally available for Rds Oracle and Rds SQL Server. Rds Custom is positioned in the middle between the self-managing database on EC2 and managed database service on Amazon Rds, where AWS does the heavy lifting of managing the database instance on your behalf. With Rds Custom, you get the benefits like the provisioning, monitoring, backup and restore, and automatic scale storage, while you are also granted access to the underlying instance. You can bring your own media for Oracle as an example, do your own custom patching, and you can also pause and resume Rds automation so that it does not conflict with the customization that you are making. Next, we look at DevOps Guru for Rds. This is a machine learning powered capability that automatically detects and diagnoses database related performance and operational issues within Amazon Aurora. Think of DevOps Guru for Rds as this monitoring tool that uses machine learning, that's keeping an eye on your database instance and immediately notifies you when it detects a problem, while also providing you a remediation recommendations for a wide range of database-related performance issues. For example, overutilization of resources or misbehavior by certain SQL queries. It natively integrates with other AWS services to automatically receive notification. When DevOps Guru detects performance bottlenecks or operational issues, it displays its findings in the console and immediately sends notification via AWS services such as EventBridge and Simple Notification Service. This will help you reduce the time to resolve issues to minutes. With DevOps Guru, you can simply understand the causes of performance or operational problems without having to search through hundreds of database metrics. DevOps Guru is generally available for Amazon Aurora with Postgres compatibility and Amazon Aurora with MySQL compatibility. There was a great capability that was announced for Amazon DynamoDB. There is a new DynamoDB standard infrequent access table class, standard IA for short. Some of you might be familiar with this terminology from working with data hosted on S3 buckets to help you reduce your storage cost. Dynamodb standard infrequent access is the most cost-efficient table class when storage represents the bulk of the cost for the table. You can switch between the standard and the standard IA table classes without impact on table performance, durability, availability, and also without having to change your application code. In an existing table, you simply go to your console, select your table, go to Actions, update the table class. After a few seconds, the table is now updated to use standard IA. And you can change back when you need to go back to the standard class. This is not the choice that will be suitable for all use cases. Standard IA table class is ideal for use cases that require long-term storage of data, but where the data still needs to be accessible in a very fast response time that DynamoDB gives. So this is not about moving data to a slower, cheaper data store. We are talking about here a pricing option where if your access to your data is infrequent, you can save money by storing it in the standard IA option. Example of this, think about scrolling through old posts on your social media platforms. When you open your app, you always mostly see most recent posts. But you may sometimes want to see an old post for like 10 years ago. Now, scrolling through that, it requires that that application be fastly retrieved and displayed to the customer so that the person does not disconnect on the application while waiting for the data to be populated. Also, another example you can think of is past orders on your e-commerce platform. This data has to be retained, but as time passes by, it is not data that is accessed frequently. So it has to be fast for retrieval, but to store it, it doesn't have to be stored in the standard storage table class when it's not accessed on a regular basis. You can save cost by moving it into the standard infrequent access. We are working on a tool which will be an open source tool that will run against your account, and it can look into your database in your DynamoDB table. And based on the historic usage, it will give you recommendations on when it makes sense to switch between back and forth between the table classes. Keep an eye out for this. We will announce it when it's available. For Amazon TimeStream, there were 3 capabilities that were added to help you store and access your time series data more economically and efficiently. With scheduled queries feature, you can define your queries along with the frequency at which the queries must be executed. Then TimeStream will periodically and automatically run the schedule and reliably writes the results of that output in a configurable destination table within a few minutes. Think of this as writing a cron job for your queries. Now, the second feature is the multi-measure records. This is a new data modeling capability that enables you to write multiple time series measures in a single table row, instead of storing one measure per row. This optimized way of writing multiple measures will help you reduce the data stored in the table, which will help you lower the data storage cost, improve your query performance, and minimize the cost of your analytical queries. The last new TimeStream feature that I would like to highlight is the ability to write late arriving data into the magnetic store so that you can further optimize your storage spend. Late arrival data is defined as data with a timestamp that's in the past. So in short, this feature allows you to store data in a cheaper storage class to keep for long-term use. Next, we have Aws Dms Fleet Advisor, which is a capability of DMS that automates the planning for customers who want to migrate their databases and analytical workloads to AWS Cloud. To help you move faster, it automatically builds an inventory of your database and analytical systems, analyze them, provide you with a tailored migration advice for your specific workloads, and provide you a list of potential migration targets, and give you guidance on the complexity of the migrations. In simple terms, it connects to the environment that you've configured. Have a look at what configurations you have, does an analysis, and then says, hey, this is the information that I got when I was doing the discovery. Here are some suggestions on what you can do to have a successful migration. Benefits of this feature are that you will reduce the cost associated with migration planning. Also, you can build a migration plan with it, and it can also help you identify which databases you can migrate at scale with minimal effort. It is currently in open preview and are available on select regions. We will roll out new features and roll out more regions as time goes on. And this is it for the bite-size reInvent recap for the databases related announcements. And now let's move on to a demo on Rds Custom for Oracle. Let us go through the AWS console and see how to create Rds Custom for RDS. You first need to create a custom version engine that you will use for your instance. So you simply click Create Custom Engine Version. Now, you must have downloaded your software from your Oracle software delivery website, uploaded it onto your S3 bucket. And now here you would point to that location where the files will be found. The manifest is very sensitive to spaces. So use this template and rather edit your file names. This way you would minimize mistakes and save yourself troubleshooting time. Then go back to the create database and select Oracle. You will then see you would have two versions, the RDS standard and the RDS custom, with Oracle Enterprise Edition as the only available edition. The custom version engine in the drop-downs will be the one that you created earlier. You can select the one that you created and populate with the rest of your database settings. The only thing that you can notice is that instances that are available and also the storage type, you would see it's the IO and the GP2 that's available in the dropdown. The rest of the other connectivity and your VPCs is as normal as you would for your normal RDS instance. You can just select and choose your options and continue. Now, as a prerequisite to creating a custom instance, you must have created an IIM instance profile, as well as have created a symmetric AWS KMS key that you would use. During the creation of the database instance, it will be in full automation mode. The rest of the other options are just as normal. Here's an example of a running instance, and you can see it's in the available state and it's in full automation mode. In the connectivity, you can see it has the endpoint, normal endpoint that you would have for an RDS instance. Under the configurations tab, you would see the resources ID. This is the resources ID for your underlying EC2 instance. Now, if you go and modify your DB instance, you can change the storage. And also you can then pause the RDS automation, and the rest of the other configurations remains the same. So if you go into your EC2 instance page and you filter using that resource ID that you copied, you will see the underlying EC2 instance. This is on your own EC2 account. You can click on it and you'll get more information, the duration of that instance. And then you should see the key pair that you would have to download the PEM that you can use for any of your SSH applications like PuTTY. And also you must make sure that the security group associated with the instance does have port 22 SSH enabled. You can also connect using Session Manager, which is what I'll do in this session. I then sudo into the RDB and database, and then I connect to the database assistDBA. Now I've SSH into the database instance. This is something that's never been possible before with an RDS instance. You can see there that it's in full automation and everything is working. Now we want to simulate shutting down the instance. The RDS automation should see that the instance is down and should bring it up. So if we simulate this, we execute the shutdown immediate command to stop the database. We can tail the alert log. We should see the database going down, but also we would then observe the RDS automation bringing the database up again. Now, if you go back, the database now should be brought up by the RDS automation. Now we can try and connect to it, and we should see that the database is back up. Now this is a capability that we haven't been able to execute on RDS before. When we go back to the RDS console, we will observe that the RDS automation brought the instance up and that the status is currently in available state. This concludes the demonstration on how to get started with your RDS custom for Oracle. Thank you.